And hello there again. Today I found one interesting task and its solution very beautiful and interesting I wish. That's why I would like to show it. Okay, what is it? Just to find all uh, real x such as both expressions are together integer. And okay, what are we going to start with? We're going to start with that the numerator power and denominator power are such as the difference is 1 and means for enough big x value it is right x, just like this. For enough big absolute value of x, sorry. Okay, let's try to show what is it. Okay, this is right, as you can see, because polynomial power is 7 over 8 is less than 1. Okay, and what can we get from it? If both of them are integer, then their difference is integer 2. 1, 0, minus 1, 2, minus 2, and so on. So, what if this difference is between minus 1 and 1 for some x value? Then it will give us that the possible solution is if they are the same. As you can see, it is very easy that we do just set is equal to 0 and find this easier polynomial task. Okay, but now let's set that this absolute value is less than 1 and find also x. Okay, we just rewrote it as two inequations, and let's just solve them for example, two cases. For x value, absolute x is bigger than or equal to 1. Okay, the first case, x is bigger than or equal to 1. Then we'll just change something. If digit is minus, we'll just add power at 1, else we'll just cancel 1 the power and so on. And okay, what's next? Later we go something like this, but its derivative is strictly bigger than 0, and f of 0 is 1. So it means for all y, but I will know that y is x squared. It means y is positive always, and f of y is positive too. Okay, what if x is less than or equal to minus 1? Just one substitution to make calculations easier, and then nothing difficult. And seems like we are done. It's why do I show this? It's just like, yes, it's obviously. So what about the blue? It is really nothing difficult. One trivial task and another trivial task. Okay, just write for x value, which absolute value is bigger than or equal to 1. So, if absolute value of x is bigger than or equal to 1, then difference between two functions is less than 1. Then they are both integer, only if f of x equals g of x. It means the same. But it means that this expression just goes to 0, which is really nothing difficult and gives us a few possible roots. We'll check them some later. So what if absolute value of x is less than 1? Then if x is bigger than 0, you can do this and prove this less than 1. It is obviously bigger than 0. I just wouldn't like to even show this. And do the same with this expression. And in other case, it is just substitution for x less than 0 and nothing difficult to. They work the same rule because seriously the difference between power is the same and nothing else changes. Okay, it means we are almost done. Then the only possible roots are plus, minus 1 and 0. So they all are right, and it means we have solved this task. Then goodbye.